Hello everyone. So today let's solve the problem Rn matrix, right? Or Rn matrix. So this was asked in Codeforces around 277, division 2, right? So let's see. You can just go through the question. I'll just summarize the question so that it will be easier to understand, right? So what the question states here, we are given a matrix B, right? So suppose let me come to the example. This part is B actually. This 2 to whatever they have given. One is m equals 2 rows, nothing but n is nothing but the column. M and n you can consider this 1, 2, 2. And this is matrix B, another matrix. So you can just consider matrix B for this one. So this will be 1, 0, 0, 0. This is matrix. So we are given a, so just give a second, just give me a second here. Yeah, we uh, we are given a matrix B, right? So we are given a matrix B where each cell Bij equals R. So here in this case, B of ij, so this one will be R, or sorry, not R, or. So this one of all the elements in row I and column j from an unknown binary matrix A, from an unknown binary matrix A. This is very important. So we are given a matrix B. So here, as I've said, this one, this 4, 1, 0, 0, 0, this is matrix B. Just keep this in mind, where each cell B of ij, this one I'm speaking of, is equals or of all the elements in row I and column j from an unknown binary matrix A, from an unknown binary matrix A, right? So there matrix A is not given, binary matrix A is not given, basically from an unknown binary matrix A they have mentioned. So what is our main task then? Our main task is to reconstruct a possible matrix A. We have to, this one, reconstruct a possible matrix A, or print no if it's not possible to construct such a matrix A. What we need to do again, it's very simple to understand. Again, I'll just read out loud, you just try to understand. Our task is to reconstruct the possible matrix A, this one they are speaking of, right? So this is unknown matrix A, right? So our task is to reconstruct the possible matrix A, or print no. If it is not possible, then we have to print no in that case, right? Or we have to print no if it's no possible, if it's not possible, sorry, to construct such a matrix A. If it's not possible to construct such a matrix A, then we have to print no in that case, right? So all the values in A and B are either 0 or 1. This one is very important. All the matrix in the A and B are either 0 or 1. This one, just keep this in mind. It is either 0 or it is 1. Just keep this in mind. This is very important, right? So let me do one thing. So let me remove this one. You can clearly see here as well. So 2 and 3 are rows and columns. This one, rows and columns, m equals 2, n equals 3 here in this case. You can see here, right? 2 rows and 3 columns we have. So that's what they have mentioned here. 2 rows, 3 columns. Here, yeah, this is fine. uh Here also 2 rows 3 columns they have mentioned here. Yes, here boolean value they have given. This is fine. So here in this case 2 rows and 2 columns we have. You can clearly see here 1, 0, 0, 0 is the matrix B. So again I'm telling, just focus on this one. This part what they have given, 1, 0, 0, 0, this is nothing but the matrix B. So we have unknown matrix A, we have to construct the matrix A. So we have to reconstruct the possible matrix A, or if it is not possible to construct the matrix A, then we have to return no, 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 right? So if it is not possible to construct the possible, matrix A, then we have to return no. I hope this part is completely clear, right? So all the values in A and B are either 0 or 1. You can clearly see here in the all, in all the examples we have either 0 or 1. The second line and the third line we are considering, right? This one. So here there is this is the matrix B basically, right? So here you can clearly see it consists of either 0 or 1. This is very important, right? So this is very important. So I hope the question is completely clear. What we need to do is completely clear as well. Easy to understand, right? I hope this is clear, right? First, what we will do, as usual, let's do one thing. Let's initially discuss the approach, right? So let's discuss the approach, then followed by the complexities. So whatever accordingly with the approach, so whatever the code that we'll be writing in the future, so let's before writing the code, let's discuss the complexities along with the approach, right? Then let's write the code. First, as usual, let's discuss the approach. I hope the question part is completely clear, right? So what we need to do is completely clear, right? So now let's discuss the approach first. So here you can clearly see I have considered the same first example that they have given in the question so that it will be easier to understand. So this was like this in the question that had given first example. If you look into the first example, they had given in this way, right? 1 0 0 0. This is nothing but m here in this case. This represents m. Number of this one rows, this one columns, right? This one rows, this one column. So just give me a second here. Did I get confused? No, right? Just give me a second here. Yeah, this is rows, this is columns, this is fine. So this is another matrix. From this itself we have to reconstruct the matrix A. This is matrix B, right? So this is matrix B. From this one we have to reconstruct the matrix A based on the conditions or the requirements I mentioned while reading the question, right? So one thing, just keep this in mind, we are going with a hash set. So we are going with a hash sets approach, right? So we are going with a hash set approach. I hope this is clear. Just keep this in mind. We will be going with the hash sets. Basically, we'll be making use of the two hash sets in this case. So just remember, we will be going with the hash sets approach, right? So this is the example we'll be considering to understand the approach. So so I didn't wanted to consider any other example because this was the easier one, and if we consider this example it will be easier to understand. Basically that is the reason I chose this example. I hope this is fine. So next let's discuss the step by step, let's go with the step by step explanation, right? So just give me a second here. So the first thing here is I think, did I miss something? No, right? So yeah, we have this one. We are considering this one. M equals to n equals to nothing but the rows and columns, two rows and two columns here. The value we have here is 1 0 0 0. So we have to mark the rows and columns that must be all zeros in A. We have to mark all the columns, rows and columns that must be all zeros in the matrix A, not in the matrix B. Matrix A, we have to reconstruct the matrix A, right? So let's loop through the matrix B. When I say loop through the matrix B, we have 1 0 0 0. This one is nothing but 0 comma 0 0 comma 1. This is 0 comma 2, sorry, 1 comma 0. Sorry, I got confused here. This is 1 comma 1, right? So just for the sake of understanding I have written this one. So at B of 0 comma 0 the value is 1. This one 0 comma 0 is this one itself, right? 0 comma 1 we have the value 0 and all other values are 0 basically. 1 comma 0 is also 0, 1 comma 1 is also 0. B of 0 0 0 1 1 0, this one I'm speaking of value 0. So we have 1. When we have 1 we need to skip at that case, right? So here why we are skipping this one, basically we have to mark the rows and columns that must be all zeros in A, right? So this one we are skipping, we are just keeping that one as it is, we are just skipping, and we are going with the next one. A must be all 0. Here we have the value 0, so A must be all 0. Here also A must be all 0 because the value is 0. Here also the value is 0. A must be all 0. I hope this is clear, right? I hope this is clear. So let's move on with the next one. So what we will do here, we will collect 0 rows, 0 columns. In this case, 0 rows, all other all other this one, three values, 0 0, this one I'm speaking of 0 except 0 comma 0. This one 0 comma 1 0 comma 0 and 1 comma 1 is having the value 0. So 0 rows and 0 columns we will be considering 0 comma 1, and for the 0 columns as well, so 0 comma 1, right? So I hope this is clear, easy to understand, right? So let's come to the next part here. We will construct matrix A. So we have to construct the matrix A. That's what they have given in the question, right? So here, if I is not in the 0 rows and J is not in the 0 columns, here, see here. If I is not in the 0 rows and J is not in the 0 columns, we will set A of ij equals 1. We will set A of ij equals 1. A of ij is nothing but B of 0 0. We went with B of 0 0, B of 0 1, like that, right? So two more, b of 1 0, b of 1 1, like that itself, a of ij. So if I is not in 0 rows and j is not in the 0 columns, then we will set the a of ij equals 1, quite obviously. Otherwise we will set a of ij equals 0. Simple to understand, right? So all rows and columns are in 0 rows and 0 columns, because 0 and 1 are the values that are present if you go to the previous step. So just give me a second, I'll just show you here. So we got 0 and 1. 0 rows consist of 0 comma 1, and 0 columns also consist of 0 comma 1, and we have the values only 0 comma 1. They have mentioned in the question it consists of only 0 and value 1, right? So all the rows and columns are in 0 rows and 0 columns here. This one I'm speaking of. All the all the this one values, I mean, are in the all rows and columns are in 0 rows and 0 columns here in this case. So what we will do, I of I of a of ij will be 0 everywhere. A of ij will be 0 everywhere because all rows and columns are in 0 rows and 0 columns, right? 0 and 1 are the values that are present from the previous step. So all rows and columns are in 0 rows and 0 columns. So a of ij will be 0 everywhere here in this case, for the example that we have considered. So now matrix A will be quite obviously 0 everywhere as per the condition, previous step. So here all rows and columns are in 0 rows and 0 column. So a of ij is quite obviously 0. Here now we have 0 everywhere. So matrix A becomes 0 0 0 and 0. This is fine. So let's come to the step 3, third step here. What we will do in the third step, we will reconstruct matrix B from A. We will reconstruct matrix B from A. Now in the matrix B, what we have, 0 0 0 0, that we know. We have 0 0 0 0 in the matrix. So now we are reconstructing the matrix B from this one. This is nothing but matrix A. From the previous step, we know this is nothing but the matrix A. Now what we'll do, we will generate B. Let's generate B from the constructed A. So this is the matrix B. We have constructed the matrix A. Let's generate the B from constructed A. B of 0 0 is nothing but R of row of 0 0 and column 0 of 0 comma 0. Nothing but R. Uh, Either side we should be having 1. If we are going with the or, logical or, so if we have 0 1, then only value will be 1, or 1 0, then only the value will be 1. Here in this case we have 0 comma 0 and 0 comma 0. So for b of 0 0, or of row 0 and column 0 of 0 comma 0, for both the value will be quite obviously 0. For logical or 0 comma 0, the output will be 0 here in this case, right? So here this one 1 comma 0 will be 1. 1 has to be present at least once, right? So it can be present on either side. So 0 0 will be 0 itself, 1 0 will be 1, 0 comma 1 will be 1 for the or. So here in this case the value will be 0. So but original b of 0 0 is 1. So we know that from the input. See here, so I'll just come here. See here, original value in the b, this one, this, so somewhere we have written b of 0 0, right? So here this one we already considered, this b of 0 0 is 1. So nothing but 1 0 0 0. Quite obviously 0 0 is 0 0, the value of 0 0 is 1. So this is 0 1 1 0 1 1, right? So quite obviously the value of 0 comma 0 is 1. But here in this case what happened, the for b of 0 0, when we are performing or here, or of row 0 and column 0 with the values 0 comma 0 and 0 comma 0 is 0, right? So but the original value of b of 0 comma 0 is 1. So now there is a mismatch, we cannot construct the b from A, right? So from this we constructed matrix A. Now we are generating the matrix B from the constructed A, right? So now we have the value 0 here. So this is having the value 0 here. This one I'm speaking of. This is having the value 0. So now we have the value 0, which should have been 1. In this case, B of 0 0 is having 1. So there is a mismatch here. So there is a mismatch. It should have been basically, if it was 0 then it was fine, but we are having 1 here. B of 0 0 matrix B, right? I'm speaking of the matrix B. Here B of 0 0, the value is 1 here in this case. But from the generated matrix A, we are trying to generate matrix from generated generated matrix A, we are trying to generate the matrix B, right? Here from this matrix we have got the value 0 and there is a mismatch here. So as there is a mismatch, what we are doing, since we couldn't produce the given B using any valid A, we will conclude final output is no. So if we cannot produce the given B using the valid A, in that case we have to give the output no. That's what they have given in the question as well. If you are not able to produce the given B using any valid A, then quite obviously we have to display false, or we have to return not false, we have to return no, sorry, we have to return no. In this case the final output that we got here is no, which is equivalent to the output that they have given for this. Basically you can just check for the first example, the output is no, they have given, right? So you can just check for the other examples. There are 3 or 4 examples I think. So you can just check for second, third and fourth example in the same way that I showed, right? If you need to know better, you can just check in the same way, you'll get the proper output, right? So I insist you to check so that you understand this problem better. In this case we have the output no. So I'm speaking of this one. In this case we have the output quite obviously no, right? So the output matches, uh, whatever the output that we got matches or equivalent, that is I mean whatever the output that we got is equivalent to the output that they have given for the example 1 in the question. So now so the approach works absolutely correct in this case, right? So the approach works absolutely correct in this case. So in so now we are completely familiar with the approach now. I think approach part is completely clear. Let's quickly discuss the complexities part so that we can write the code quickly, right? So I'll just come here. So this is come finished, right? So yeah, so the time complexity will be big of m into n, and the space complexity will be quite obviously big of m plus n. Why the time complexity here is big of m into n? So let me tell you one thing. The time complexity is big of m into n because we are iterating through the matrix 2 to 3 times. We will be we haven't written the code yet, but we will be iterating through the matrix 2 to 3 times, because we have to first we have got the matrix B, then from that matrix we have to generate the matrix A, right? So from the generated matrix A, whatever the matrix that we generated, from that matrix again we have to generate the matrix B to check whether that works or not. So that's what we did in the approach, right? So we will iterate through the matrix 2 to 3 times, each of size m into n. So overall time complexity would be quite obviously big of m into n in this case. So what would be the space complexity here? Space complexity would be big of m plus n. Why it is m plus n? Because we are storing the 0 rows and 0 columns using hash sets. So 0 rows, whatever we spoke of, whatever we discussed in the this one, what do you call, uh, approach, 0 rows and 0 columns. I was repeating this one again and again, right? 0 rows and 0 columns, these things, 0 rows and 0 columns, we are storing this one in the hash sets. When I say hash sets, we will be making use of the 2 hash sets. So that's what I meant, right? So we are storing 0 rows and 0 columns using hash sets, nothing but the 2 hash sets. So overall time complexity is big O of m into n, and the space complexity will be big O of m plus n for the code that we will be writing. I hope the approach part is completely clear along with the complexities. Now as we are familiar with the complexities as well as the approach, let's start writing the code. So let's start writing the code. Initially, I'll just come here to the online compiler. I'll be making use of the online compiler. So let's import the utilities first. So I'll just go with import java.util.star. This is fine. So the next step here is, let me make use of the class. Let me give here public class. I'll just go with the Bharadwaj. This is fine. So let me give main here. So this is fine. What happened to this one? This is fine. So within the class, first thing we have to read the input. So I'll be making use of the scanner. So this one will be sc. So this will be new scanner system dot in. This is fine. So I don't have any problem. So we don't have any problem. The next step here is, so we need number of rows in the matrix, and also we need number of columns in the matrix. When I say we need, quite obviously we have to iterate through the rows and columns, right? So we need number of rows in the matrix and we need number of columns in the matrix. So I'll just make use of m and n. So we have already discussed this one in the approach. That's what the same thing I'm articulating in the form of code here. So m equals sc dot, so I'll just give here next int. This is fine. So let me copy the same thing here again. Let me make the necessary changes for the columns here. This is for the rows and this is for the column. So I'll just go with n here in this case, n, right? So I hope this is fine. Yeah, next part is, let's go with the input matrix b. First, we have to go with the input matrix b, right? So accordingly with the approach, so I'll just give here int b equals new int of this one, rows and columns, nothing but in this case m and n. I hope this is fine. This is nothing but the input matrix b. So we have to go with the two for loops as we have, as I have mentioned earlier. So this one will be int I equals 0, I less than m, I plus plus. This is fine. For this one will be int j equals 0, j less than n. So this one is j plus plus. So this is fine as well. So now we have to read the matrix b. For reading the matrix b, I can just write in this way. If you remember, b of 0 0, b of 0 1 we did right during the approach. So the value I showed, and for the value b of 0 0 it was 1, and we need to skip because uh, we had to skip because the value was not 0 initial step, if you remember. So that's what we have to read the matrix b. For reading the matrix b, I can articulate in the form of code in this way. So I'll just give here sc dot next int. So this one, this is fine. So this is just for the just for reading the matrix b. So the next step here is, so we have discussed this one earlier many times. So I said we'll be making use of the two hash sets. Why? Because we have to store rows and columns, right? So we have to store rows and columns that must be all zeros in matrix a. So for we have to store the rows and columns that must be all zeros in matrix a. So let's make use of the hash set here in this case. So I'll just go with the hash set. So within the hash angle brackets, I'll just make use of the integer. So this one will be 0 rows and this one will be new hash set. New hash set. Within the hash set, let me make use of the angle brackets and let me make use of the parenthesis here. This is fine. So let me do one thing. Let me copy the same thing here. Let me paste it over here. This is also same. Instead of the rows, I'll just go with the columns here. So we have to go with the 0 rows and 0 columns, as I have said this one earlier multiple times. So let's carry on with the first main step here. So what's the first step? If you remember the approach, if any cell in B is 0, if any cell in matrix B I'm speaking of, if any cell in B is 0, then we have to mark that row and column to be 0 in A, right? If any cell except the first value we had 1, right? We had 1 for 0 comma 0, b of 0 0 1. That's the reason we skipped that one, right? So if any cell in B is 0, we have to mark that row and column to be 0 in A. So we had 1 comma 0, right? So 1 comma 0, so we in the row, in that row, so we marked whole this one, whole thing as 0 comma 0 itself in the matrix A. We were reconstructing the matrix from B, from the given matrix B, right? So that's what we need to write, the same thing, the same approach we need to articulate in the form of code. So here this will be int I equals 0, I less than m, and let me increment the I here. This is fine. So no need of braces here, bracket, sorry. So this one will be int j equals 0, j less than n. This one will be j plus plus. This is also fine. So here in this case, if b of I j, this one, if it is equal to 0, then what we will do, row I must be 0 and column j must be 0 as well. So here in this case, this will be 0 rows dot add of I. So this one, so row I and the column j must be 0 here. So row I we made 0 by making use of the add property, and let's go with the 0 columns this time. So 0 columns dot add of j here. So we have successfully made row I and column j as 0 here in this case, right? So this is fine. So let me come out of this one entirely. The next step is we have to construct the matrix A from the given matrix B, right? So for that one, let's articulate the same thing in the form of code here. Let's write this one fast, right? So int, this is fine. Let me consider the variable name A, as we have to construct the matrix A. So this one will be new int of row and column, nothing but rows and columns, nothing but m and n, right? So this is fine. So again, two for loops here. This one will be int I equals 0, I less than m. This one will be I plus plus. So this is fine for the column. So I'll just go with int uh, j equals 0, j less than n, j plus plus. So this is fine. So the next step here is if not in 0 row or and not in 0 column, then we have to set a of ij equals 1. If it is not in 0 row and if it is not in the 0 column, then we have to set the a of ij equals 1. So how can I write that? So if a of ij, this one, as I've said, not in 0 row and not in 0 column. So this one will be not of 0, this one 0 rows. I'll just make use of the contains, built-in contains of I. And so let me copy the same thing. Instead of rows, I'll make it as columns. So this one, this is fine. Instead of rows here, let me delete this one, and I'll just go with columns. 0 columns dot consist of this one will be j instead of I. This is fine. Consists of j. Then what we will do, let's display 1. Else what we will do, will display 0. I have made use of the ternary operator here. This is fine. I hope this is completely clear, easy to understand. So the next step is after constructing the matrix A, so from that matrix A, again we have to generate the matrix B from A. So we did the same thing in the approach. Exact same thing, whatever we discussed in the approach, exactly the same thing we are articulating in the form of code, right? Whatever we discussed in the approach and whatever the complexities that we discussed, same thing, exact same thing from the approach. I mean, whatever we discussed in the approach, we are articulating in the form of code here, right? Accordingly with the complexities that we discussed. I also said that we'll be making use of the two hash sets, and after constructing the matrix A, the next step in the approach was to generate matrix B from A to verify the correctness, whether the matrix is correct or not. So in our case, it was a mismatch because instead of 1, we had the value 0 at 0 comma 0, if you remember. So here in this case, what I'll do, let's generate the matrix B from A again to verify the correctness. So I'll just come here. Let me give int this one B prime. So here this one will be new int of m comma mn, right? So for I'll just give int I equals 0, I less than m. This one will be I plus plus. So this is fine. So let me go with one more for loop here. For int j equals 0. So this one will be j less than n. So this is for the column, right? So j less than n, j plus plus. So this is fine. Within the for loop, what we need to do, so we have to go with the or, right? So we have to perform a logical or. The question itself says that or in matrix, right? So here what I'll do, I'll just consider the variable or here and initialize that one to 0. It acts as a counter right here. So we will be performing or logical or of row I, and we will be performing logical or of column j. Here in this case, let's write the simple for loop. First let's perform or on or of row I. Here for this one, I'll just go with for int k equals 0, k less than n, k plus plus. So I'll just make use of or here. So for the logical or, I'll be going with this symbol, or equals. So this one will be a of I and this one will be k. So this is fine. Next, what we will do, we will be performing logical or of column J. When I say we will be performing logical or of column J, again we'll be making use of the another for loop. So I'll just copy the same thing and make the necessary changes here. So let me come here. So let me paste it over here. Instead of K, here also it will be K itself. So here what I did, K less than N I have given. I'll just make this one M. Basically this remains same, or this one remains same. This one will be a of kj. This one was a of ik. This one will be a of k and j. So I hope this is clear. The last step is we have to store the result in this one b, matrix b, right? We have to store the this one result in matrix b. So we have considered the this one, what do you call, b prime variable. So b prime of ij, we are storing the results in matrix b. For this one we have considered r itself, right? Somewhere this one, yeah, the same thing. We are assigning this one to the r. We are just storing the results in the b, right? So I hope this is clear. So next step, so let me do one thing. I'll just come out of this one entirely. Yeah, the next step is we have to compare b with the original b. So we have to compare b means this one, matrix b. So this one we were verifying, right? So we have to compare the b with original b, right? We discussed same thing in the approach. So let's write the same thing here. So I'll just go with a boolean. uh, I'll just go with is same. Let me initialize this one to boolean value true. Again same two for loops. I'll just copy the same thing, man. Here I don't want to type this one again and again. So let me paste it over here. So this is fine. I don't need brackets here. This is fine. Without brackets it works. So here in this case, I equals 0. So here this will be I less than m. This is fine. And also we are going with the isSem. We have initialized the boolean value isSem to true, right? So and also we have to consider this one boolean value as well. So isSem. So same goes with here as well, and isSem j plus plus. This is fine. So after the for loop, what we'll be doing, let's write the simple if condition. If p of I j, if it is not equal to p prime of I and j, then what we will do, let's initialize this one. Let's assign is same to the boolean value false, right? This has to be equal. Basically means we are comparing this one with the original b, matrix b that we generated from the matrix a finally, just to verify, right? So that b, whether that is equivalent to the real matrix b that they have given for the input, if you remember in the question. So we will check whether it is same or not. If it is not equal, then we are this one, we are assigning is same to the boolean value false. I hope this is clear, easy to understand, right? Let's come to the next step, or the final step. So when I say final step, we have to output the final result, right? We have to output the final result. So let me write the simple if condition. If not of is same, so if not of is same, then so if the value is not same, if the value of the generated b from matrix A is not same as the original matrix B, then what we will do, we have to display the output as no, no, no. That's what they said in the question. I have said this one multiple times during the approach as well, right? So here let me make use of system. Let me write println here. So yeah, this one, what we need to give here within the strings, I'll just give no. I hope this is completely clear. This says that it is not possible to construct such matrix A, means uh, such matrix A, yeah. So in our case, for the first example, we got no itself. Please, I insist you to try for the other inputs as well, right? So that you get the desired output. You can, if you are able to construct the matrix, you can just see that output as well, right? So I just insist you to see, uh, try it out for the other inputs as well, right? So here in this case this is fine. So else what we will do, um, else if valid a is found, then we have to display that one, right? So then we have to print the row. What How can we write that one in the form of code? Again, I'll just go with println. Sorry, why this is taking println itself? So let me give println. Yeah, this is fine. Mm, so we will display s. After why we are displaying s? Because valid a has been found. Nothing but we were able to construct the matrix A, valid matrix A from the original matrix B, and we were able to verify that one from the another B, right? So then we will be displaying yes. If we are able to, if we found a valid A, then we are displaying S. Along with it, we should be able to print the row, right? So we should be able to print the row. For that one, I'll be making use of the simple for loop here. This will be int I equals 0, I less than m, then I plus plus. So here in this case, um, let me give this one. Let me make use of the flower places as well. So here, let me copy the same thing. I don't want to type this one again. So let me copy the same thing. Let me paste it over here. So let me delete this one. This is not required for this. So this is fine. Yeah. Let me open the flower brackets here. So within the for loop, what we will be doing, we have to print the row. Again, for printing, I'll be making use of the print ln. You would have already guessed this one, right? So, or I can just go with the system.out.print when no ln is not required here in this case. So I'll just go with a of I j, and let's append this one, or let's concatenate this one. I'll just leave the space here. We are just printing the row, particular row, right? So this is fine. So the next step is we should go to the next line after each row, right? We have to go to the next line after each row. For that one, I'll be making use of, again, let me give println here. So this is empty. This will be empty because we just have to go for the new line after each row. That's it. So this is it for the code. So yeah. So let's see whether this works for the provided inputs or not. So I'll just copy this input. We have to get the output. No, let's see whether this works or not. I hope this works, man. So what error we have here? Error, mm, not a statement. Line number 23, 26, 27, 28. 23 here. What mistake I have done in the line number 23? 13, sorry. Um, ij, this one equals I have forgotten. This is fine, right? Equals I have forgotten here. Just give me a second here. Yeah. Semicolon expected. Semicolon, I have given semicolon right here. This is fine. Let me run this one again. I hope. Yeah. Now line number 26, what we have? Illegal start of type. So here line number 26. Let me come to line number 26 here. Equals for. So what mistake I have done here is in the line number 20, I have forgotten this one, flower bracket. So this is fine. Let me run this one again. So reached end of file while parsing. This is asking. So yeah, here also there is no need of bracket basically here in the line number 56. So I had forgotten bracket in the line number 20. This one, it doesn't require flower bracket here. So now this has to work. Let's see whether this works or not. So yeah, now you can clearly see the output that we are getting here as no, right? So we are getting the correct output here, no. So let me copy this input. So the output that we need to get here is yes, triple one and triple one, right? So let me give here this one. We're still getting no. What's wrong here? So yeah, here in the line number 28, what mistake I've done here is, so here this has to be not of 0 rows dot contains of I, right? So for both we have to mention not here. So this one, while explaining I explained correct, I think. While writing I didn't write not symbol at all. So I think, so let me run this one again. I hope this works now. Let's see. Yeah, now we are getting the output yes, triple one. triple one. So yeah, we are able to construct the matrix A from the matrix B for this one. Yeah. So let's do one thing. Let's take the third input here, 2 3 0 1 0 1 1 1, nothing but we have two rows and three columns here, right? So two rows and three columns. So this one 0 1 0 and 1 1 1. Here for this one, yes, we are able to construct matrix A from the matrix B. We have to get the output triple zero 0 1 0. Let's see whether this works or not. So what happened here? 0 1 0 1 1 1, right? So yeah, this one I've already copy pasted. So yeah, we are getting yes, triple zero and 0 1 0. So we are getting the desired output. So the code works absolutely correct in this case. Let me do one thing. Let me copy this one. Let me paste it over here. Just give me a second. Yeah, this is fine. And yeah, let me hit the submit button. I hope this works. Let's see. Let's see whether this works for all the test cases or not. So let's wait for some time. So one more thing, again, I want to tell you the same thing. I have just showed you by considering the first input. So this one I have considered, right? So yeah, you can clearly see here accepted. Just one second. So here I have showed you for this one. So in the approach, how we got no. So you can just check for the this one, how we got the output. We are able to construct this one matrix A from the matrix B for this one, right? So you can just consider the second example or the third example or the third input they have given here, right? So that one you can consider, and you can just see how we got this output 0 0 0 0 1 0, or how we got this output basically double triple one triple one. You can just check that one. I insist you to check that one because you'll understand the problem clearly, right? So you'll understand the problem clearly. So this is it. You can clearly see here uh, the code got accepted. Whatever the code that we wrote is completely correct because it got accepted, right? First, what we did initially, we discussed the problem. Later, after discussing the problem, we designed an approach and we discussed the approach along with the complexities before writing the code. Then we wrote the code. Now the code got accepted. I have submitted the code and the code got accepted, right? So the we have written the working code, right? So now I hope the solution part is completely clear accordingly with the question. So for now, this is it. Thanks for watching, guys.